Thank you all for coming. This one is going to be slightly different than what you are used to, and you'll understand why in a moment. So we're going to do a beer recommender system, or ish, something close enough, and it's really just a good excuse to show you how to build better ML pipelines. And by better, we mean more easily, more fast, and in a way, a bit less complex systems, or building complex systems with simple tools. And we're going to use the real-time AI Lakehouse that is Avstreikh. I'll explain that later. Prerequisites, if you actually want to run the code while I'm going to talk about it, you can clone the repo, get a free account on Avstreikh. We're going to use food, like business sort of API. It's called best time. And the rest is just your average Python libraries. 3.10 recommended, otherwise you might have some conflicted stuff happening. We do support 3.11, but depending on the use cases, better stick with this. So it might take some time to download. You have a few people, so I'll go into, let's say, the intro explaining what we do, show a bit of the abstractions, and in the meantime, you can just download it. So I'm Lex. I'm the head of strategy at Avstreikh. I'm a former creative director, a former designer, a former copywriter. I worked a lot with startups. I made a few myself. I'm currently kind of an idiot. So the reason for that is because I decided to come here and explain to you people how to do Python stuff at a Python conference, while in practice, I don't know much about Python myself. And I thought it was a great idea. So let's see if it goes about that. Luckily for me, I have my emotional support engineer here that has much more experience in engineering and all those things. So I think we're going to do well. So Avstreikh, just let's say the quick marketing thing. We are a lake house, not your typical lake house in the sort of like what we do is orchestration, compute, data management for everything Python sort of data. We support Java, Scala, and so on. We don't have to mind about all that right now. We also just really freshly got a paper presented at SIGMOD, which is a sort of very large database conference in South America. It's a good paper. You can read it. It's great stuff. It's important only for one reason, or let's say there is one amazing stuff that happened in this paper. Is like we benchmark against SageMaker, Databricks, Vertex, and yeah, we are better, which is good for a European company. And so just check it out. You can download it directly on our website. So sort of the normal thing to say, we work with lots of companies. We also work with smaller companies. We work with startups. We work with academia. We work with a lot of research institutes. And what we have learned essentially is how to build better ML pipelines. We are not all of us specialists in data science or Python at all, but what we've learned is how to make an MVP, how to make a minimum viable product or prediction service that you can put in operation, put in production, and in a couple of days. In some case, a couple of hours. And that's what we're going to do today. So a few things that you need to understand on why are the motivation in trying to build those systems and services the way we suggest you to do it. It's because essentially it's very hard to operationalize. Typically, if you're not a large enterprise, it's kind of hard to do an ML system, like something that can actually embed into an app. If you're not a specialist or if you're not doing stuff with LLM, it's sort of harder to even extract value because not everybody sees the value in some of those simpler models. It's typically slow to build, especially in big organizations, and it's expensive. And so in our case, and for what I'm going to present today, it's going to be easy. You're going to see the value right away. It's going to be rather fast, because it's going to take us like an hour. And it's going to be inexpensive because it's going to be free, in your case anyway. So you can use it for free. The reality is that it's all complex because of the number of data sources. So when you talk about multimodality and all, really, different models come from different appreciation of the source. So In our case, we can use data warehouses, a database, or files, etc. But like the real value comes from the real-time data. What's happening right now? When the context changes, can my model actually take that in account? But if I do only that, maybe I don't have enough information. Maybe my customer information or the personal information is in a data warehouse. And accounting for all of those disparate sources, all of those different cadences, all of these different data types, and all of those sort of schemas and complexities is what makes those complex systems more complex. And what you want, ideally, as a user, as a practitioner, is to abstract that away. What you want to do is build the models, get the data, regardless of the source, regardless of the format, and get that fast. Your second problem, especially in ML systems, is that this ecosystems of framework is just exploding, which is sort of a nice thing as well. But if you work in enterprise, you know that integrating some of those frameworks takes months because, well, you have to argue with your colleague, you have to figure out which one is the best, and so on and so forth. And the thing is, some of those tools are just amazing, yeah, really, really good, but maybe you're stuck on Spark, you want to use Flink, but you know, real-time is not real-time in Databricks, so perhaps you want to do something else. How do we integrate that if you're already part of, you know, if it's already part of your ecosystem? This is sort of like a new complexity that's added. And the third one, which is what people call MLOps, which is essentially DevOps, which is like, I need to version, I need to govern, I need lineage, I need monitoring, and if I don't have any of those things, what I do have is just a little model in my laptop, and I can showcase that to my colleagues, that's great, but that's not an operational system. So to build an operational system, you need to solve all those three things, ideally, or most of them. So I'm gonna just skip that. This is how we do it. This is, let's say, the architectural diagram of all the inwards of our platform. You don't have to care much about everything, but you have to care much about the APIs at the top, because this is what we're going to work with. Everything else is just an abstracted sort of storages and databases and engines and connectors. And sure, it's cool to work at that low level, but if you are really just building a system, what you want to do is write data, retrieve data, train, and infer. And I'm going to show that a little bit after. Moving on. We are deployable everywhere. Kubernetes is coming in a week time, so that's going to be super cool. And one thing that we've learned building systems for our partners, customers, and users is that it's kind of nice if you have an overarching theme that helps you follow, let's say, good principles on creating those systems. In our case, because we originally come from research, it was the FAIR principles of data stewardship. So we did that with the HEAP project. So that's a Human Exposome Assessment Platform, that's genetic research on the European level. So when we started working with them, they're like, okay, we need to follow with those principles because that's what will make our project sustainable over time. If we use closed framework, DSLs and all, how can we actually make this system be usable by other people, and so on and so forth. So when we implement capabilities or features and all, we are like, okay, how do we make it so that essentially we are invisible, but people can just use and reuse whatever they want and whatever frameworks they want and access the data the most easily possible. We are not only talking about it. My colleague, Jim, who has a talk tomorrow, is also writing a book about it, so ML systems, with a feature store or without, up to you. First chapter's out, so just check it out. All right, so now that, let's say, the generalities are out of the way, let's talk about a bit more on the technical side about the pipelines that I will actually show you how to do. So this is I think, MLOps sort of journey that Google gives you. If you go Google right now, MLOps Google, you'll get on their page, and they will tell you, this is all the boxes you need to check to create an ML system. I tend to disagree, but I mean, it's not necessarily false. You might need most of those boxes. But this is built for two sorts of people. Consultants, because they need to sell an hour of consulting for each of those boxes, and Google, because they need to justify that they built that. You are not Google, Some of you are consultants, the good kind, I'm sure, so you don't need this. You need a simple framework, a mind framework, that helps you build actual systems. So you need 3 pipelines. Oops. Yeah, well, I just said it. Let's imagine. You need 3 pipelines. You need a feature pipeline, a training pipeline, and an inference pipeline. The feature pipeline gets in the data, gives you back the feature and labels. From those features and labels, you will generate a training pipeline that provides you the model. And from those models and features, so those 2 previous pipelines, you can get the prediction. Sort of looks simplistic, but we're actually going to show you how it's done, and you'll see that it actually works. And it doesn't matter the scale of the product, it doesn't matter the scale of the data, it doesn't matter if you have a small, like in-house model doing something or a big project, it will work regardless. So looking at it, it sort of looks like this. Data in the feature pipeline, then you do the training, inference, and prediction. What you'll notice, though, is that there is no arrow connecting the feature to the training to the inference. And you wouldn't want that, because then you would create some sort of monolithic pipeline that you will need to essentially re-engineer each time. What you want to do is essentially to have an intermediate layer. Forget Hopsworks, it can be anything you want. I mean, it can't, but let's imagine it can. Forget about, let's say, the framework you want to use. Consider that you need a storage system, a data management tool that allows you to write and read depending on what you do. And if you do that, and if you do that well, you can essentially use any frameworks, any training frameworks, and any execution engine, and so on and so forth. And by doing that, what you have to care about is essentially doing a feature pipeline, a training pipeline, and an inference pipeline, using whatever technology you feel more comfortable with. Then, obviously, you can even do a bit more. In our case, we use Kserve under the hood, so you can do serving, you can do model registry, scale to 0, etc. But we also use orchestration. I'm not going to go in depth on the orchestration. I think people sort of know how to do a cron job and Airflow, so just do that. But eventually, with those pipelines, what you do is you orchestrate them the way you prefer, and then you use whatever framework you want. So the only additional aspect that you need to understand is more like on the abstractions levels. We created 2 abstractions that sort of help us empower this framework. So we have feature groups, which is essentially tables. They all come at different cadences from different sources. So you can use any framework. You can use Flink to do a feature streaming, a streaming feature group, and you can write it on the fly, or you can use any other sort of feature engineering method, pandas and whatnot. And what we do that differs from about everybody else and allows us to actually give you the system in a very simple way is that we have a view over those tables. So what essentially this allows you to be is to be fair. So you can reuse the data. You can have non-destructive sort of operation where you can map the view to the model, and you can have multiple models having different views using different features in each of those models. And because you will not apply the transformation in those views, you will apply them on retrieval, you can reuse as many features for as many pipelines as you want. What it means is everything is reusable, everything is versionable, and you have just a better practice. And you can use all the systems to do that, obviously. And at the end, you can also look back the prediction, and perhaps if you do some LLMs and all, you might want to do some fine-tuning and all. So, conclusion, forget about this. This is what you need. Just bear with me. All right, so what are we going to do? We're going to build an MVP. It's not going to be perfect. As I said, I'm sort of an idiot. I decided with Ray's support, although he didn't have much choice, to actually redo something from scratch 3 days ago. So yeah, it's going to be great. So what we're going to do is we're going to define essentially what are our data sources. The prediction problem is I want to know to which bar to go in an hour from now. And if I ask an LLM, it will probably give me an answer, but an LLM actually doesn't know about the best time or the time of now and such things. So as I mentioned before, we're going to do 3 things. We're going to do a feature pipeline, a training pipeline, and an inference pipeline, and that's going to build an MVP. And the reason we're going to do this in this order, and the reason I'm calling this an MVP, is that my model is not going to be that great. My inference is not going to be that great. My feature pipelines are not going to be that complex. But because I will separate all of them, I can actually augment them. I can improve my model tomorrow if I want. I can add new feature engineering logic afterward. And if you look at the notebooks, you have some optional notebooks, some of which are on the embedding side of things. That's the thing you can just add. But because the system in itself is already end-to-end, it's already done, it's already running, you can incrementally improve each of those parts way more easily, essentially. So, yeah, it's a real-time problem with some LLM on top. That's what we're going to build. So I just have to do a little sort of rant. It's a small rant. But like, I've talked to hundreds of data scientists and data engineers, and it seems to me that not everybody really understands what real-time means. Most of the time, people think it's the time of the inference. Like, oh, you know, when I ask ChatGPT and it answers me, real time. And I ask an actual question of now, it answers me anyways. So that's not really what real time is. Real time is when when your model is context dependent. So when you need to change something depending on the context of now, or the latest values of that context. So a new prediction in relation to new data. So that typically works in those three use cases. You have anomaly. So an anomaly happens in the market. You need to be knowing, I mean, your model needs to know now. TikTok is sort of the poster child for real time, because every time you actually scroll, it will send the events to the whatever engine they have in the back end, and it will probably give you a new prediction on what is the best video for you after. But that happens on the fly. That doesn't wait batch days, or it doesn't work as a batch system, which would be something like Spotify or whatever. They do batch systems. They say, okay, every week they will give you a new prediction, and those are the best songs for you this week. TikTok does this on the fly, so that's a real-time thing. And then you have other things like change of circumstances. So we have a good tutorial for that, although it's not event dependent, as in the event does not trigger the model, but you could make it. So the typical use case here would be, I have a sensible health condition or whatnot, and the air quality might drop in the next hour. I might want to know that now rather than in the next hour. So if you have a prediction service that can actually look at the real-time data, provide you that real-time prediction, and then give you back that answer, that would be a real-time service. So what depends here, what's important here, is the time between the writing of the data until the moment it's available for the model to make a new prediction and give you back the answer. And that can be, in some systems, minutes, but if it's critical, and typically in finance and all, it might be a bit more critical, we need that to happen in milliseconds. So that will be real time. Not near real time, real time. All right. And so what we're going to do here, or we're going to attempt to do, so as the model cannot know where I am, at what time I will do the query, and what are the current circumstances of the bar around here today, well, it will only be able to give me this information until I do this query. So that would be a sort of real-time system. So you could do it without any LLM, and typically that will sort of work like that. Not too pretty, but I did my best. So the real-time context is I'm near here, and I want to find the best bar in an hour. Typically, you would have a script or anything that will just give an input to the model, and you will get back the output from the model, and you will interpret it through a UI, through another program and all. Where the LLM comes in, and that's the sort of interesting aspect, it sort of becomes a reasoning engine to interpret both that query and the answer. So if I ask the model, the model to find the best bar in an hour, instead of me adding those query to the model, the LLM will call a function or something else, do that query, get back an answer, interpret that answer, considering maybe perhaps my circumstances, where I am, what I like, and then interpret that answer and give it back to me. So it becomes a sort of reasoning engine. Not amazing reasoning, but sort of a minimalistic reasoning engine. And eventually, you can do a bit more complex stuff. You can make the LLM choose between different models to query. So that's function calling. If you are interested in function calling, I'm not capable to tell you about it, but Jim Darling tomorrow has a talk about it, and he's fairly capable to talk about it. And what's the difference here comparatively to another systems? Like, if you do this with vector databases, perhaps it's a bit too slow. So what you would want to is to have the access to those embeddings in real time, because eventually you don't have always your personal data in a vector database. The last users' information, the last clicks are not in a vector database. They will be in a warehouse. So that's where you need to be able to query them. All right, I have this other example if you're interested, much more interesting tutorial, a bit more complete into the function calling side of things as well. And yeah, so it's a nice repository. All right, let's look at code eventually. Do you want to take some? Yeah, all right. He'll talk a little bit, then I'll show the code.
Hi everyone. I'm a little bit hoarse, so apologies. Raymond Cunningham is my name, and I think as Lex highlighted, I've been working with startups for close to 20 years or 20 plus years, helping them scale from 2 people to over 100. And so when I joined HopsWorks, just like close to 2 years ago, I was trying to figure out, my background was in enterprise software as a service, building web apps, mobile apps, all very interesting, and all this new machine learning comes along, and you're trying to figure out what the hell is going on, right? And so when I was understanding HopsWorks, what I was trying to figure out was why would I, as a user or as a person who has bought software in the past, why would I buy this? What's sort of its value add, right? And the key thing, which I think Lex is going to show in a few moments, is that you're not seeing any of the infrastructure, but the infrastructure is behind the scenes, right? So you're probably people who are in the machine learning space, or you're data scientists, etc. You probably spend your day possibly in Jupyter figuring out how to get your model working, but there's a whole set of infrastructure that needs to be put in place to bring that model to production. Now, for enterprises, which we serve as from a HopsWorks perspective, enterprises basically have no issue with just basically buy the software. It costs this money. We have this number of data scientists with this number of machine learning engineers. It completely justifies the productivity gains from having it. But if you're working in a startup, right, you're probably pulling various different pieces of open source together, plugging it in, getting it working, and you'll figure out over time that as you grow your company, right, from maybe a couple of co-founders, you hire your initial set of people, you'll eventually start to realize that what you pull together in terms of open source starts to have some, let's say, growing problems, right? So you basically use maybe MLflow, or you use various different tooling, and then you figure out, well, we've gone from 5 people now to 15 or 50, and it's not working as cleanly as it once was, and your infrastructure is sort of holding you back, right? So behind all this, and I think Lex can go into it if we have time, behind all this, we were sort of doing the app, showing you how easy the app is to build, but the intention is that there is some infrastructure behind, and we can sneak peek behind the curtain of the infrastructure, so that it's been built on solid foundations. Okay, with that, like if you've just sort of landed on Earth in the last day or so, you probably don't know what an LLM is or a foundation model, but I'm pretty much assuming everyone does, right? And we've seen huge increase in the number of models. It's super, super exciting space, and people are starting to use it for solving real world problems, which is great. And there's this idea of a base model and a customized model. So your base model is sort of general purpose, and then your customized model takes what's called either non-parametric knowledge by attaching some sort of documentation, so like RAG or doing prompt engineering, etc. You're just basically doing some custom documentation that you're basically passing into the LLM, right? And there's various different techniques that people have developed to do this sort of customization, like prompt engineering. We can talk about those in a bit. So we basically went from this, which is because there's so many LLMs in the space, you have to ask the question, which one should I choose, right? And ultimately, if you're engineering this in a thoughtful way, you'll try and defer a lot of these decisions so that you have flexibility over time, right? And this is why things like LangChain have become super popular, because they give you that sort of level of indirection where you can get to choose the model, push the choice of the model further out, right? But if you are choosing an LLM, you have a number of different things to be aware of. You've sort of performance, latency, size, cost, hosting, how do you get deployed, how do you evaluate it for various different forms of goodness, whatever goodness means. So in this tutorial, we're using LangChain behind the scenes, and we can jump into that if there are any questions, etc. But this is just background. Okay, so the best bar an hour from now. I know we've been talking for long enough. It needs to be real time, so you need to be pulling data from somewhere in real time, like it's to the minute. Some form of personalization, and we want to use LLMs, so that's what we said we'd talk about. So we're going to do it with 3 notebooks. There's a couple of optional extras we might get into. I think Lex, you're going to walk through the notebooks, just to show that it's not, you don't have to have a lot of scars from previous engineering to be able to get something simple up and running in a model that works with an LLM. So I'll hand over to Lex.
20 years ago. So I guess I could do some. All right, so I'll just keep this as a background because I'll probably jump back to that back and forth. So that's sort of the highlight of how everything works. So where we're going to start with, the first notebook, is the feature engineering one, so in the feature pipeline. So let's go. 12, all right. Oops. All right. You can use VS Code as well, but I tend to have a few issues with it when I try to run it. So it's I find Jupyter somewhat better. So, okay. So assuming you already have an account on HopsWorks, right? And assuming you already have an account on BestTime, so you will have those 2 API keys already available. What we're going to do is simply import HopsWorks and pandas. The rest is sort of not too necessary. So what I'll do here is first I'll run this. I will just set my new feature group. I can do a new version, and we can do this live and see if it actually works. Just rerun the cell. Yeah. The exclude is what I don't commit to the GitHub. So it's my GitHub in your folder. So that's where my keys are. So if you look here, there is key.py, right? So I actually import the folder, import the key, and that's where it is. I don't know if it's the most elegant way to do it. It's just the only way I know how to do it. So bear with me. By the way, if you don't want to call any APIs and all, you can also just get the sample data, and you'll have the CSV of what you would be pulling from the BestTime API. I do think they provide around 200 credits, which I don't know what sort of unit it is, but it gets you quite far, if I'm being honest. So in my case, I will create this new table, which is called a feature group, right? And I will call it bars near London Bridge, because we are sort of around here. And I will make a new version, which is 4. You don't have to create a version. A version will happen automatically. It's just that I have many versions, and I did it many times, and I'm sort of panicking if something starts not to work, so I'm going to start with a new version. The number of bars is up to you. We can increase or decrease that, and that's about it. So again, we're running. Connected. So if you have an account, you can actually click on the thingy, on the URL, and it will just bring you to the UI. So this is the serverless app. there is things that it does not have. It has all the same APIs, it has all of the same, let's say, general usability if internet works, otherwise not, because it's online. Let's imagine it does. But what we don't provide for free, it's mostly the orchestration, because it would cost us a little bit. So there is a back-end orchestration for running all the jobs and all of those things, but you don't have access to the orchestration itself, not through the UI, which you would have typically within an enterprise. So this is the project I have. I just connected to it. I happen to have already a few feature groups. As I said, those are tables. We don't have to look at this. It does not matter. What we're going to do first is actually create that feature engineering pipeline I was referring to. But before, we need to create the object we want to insert data into. In our case, that's called a feature group. So we're just going to do get or create feature group. As I already provided the name and already provided the version, I just need essentially to just get a description, a few primary keys if I need, can be just one, and an event time. Here, this is some of the things that's super cool that you might not really understand right away what that means. This actually means that it writes the data in an in-memory database as well as the offline storage, meaning that all the latest values will always be available at low latencies. And then it will sync the data into the offline storage, materialize it in the offline storage periodically. You can choose what's the periodicity of that. But typically, what we just did here is like, if it's an online or offline data, it doesn't matter anymore because we're going to materialize it. So as a user, you just don't care. So obviously, what you can do is also query that object. I think I have that in a training pipeline just as a data frame, see what's in. It's a table, right? So you will get table data. So then we're going to use the best time API. So that's the one for the foot traffic data. Just the number of bars that I passed earlier, the location that I passed earlier. And actually, did I run this? Oh, let's imagine I did. All right, I'm going to run this as well. Obviously, because I don't run those cells right away, just put them here. It's not going to work right away, but we're going to work it at the end. So it's just going to, it's sort of a slow process. So typically, this is what you would want to actually orchestrate every hour, every whatever periodicity you need. You just put that in a cron job and say, run this, insert it in the feature group, and then whenever you actually do the query, it will be available in real time. This is real time, as in we do the query in real time, but the actual context doesn't really change in real time in that case, because the foot traffic data that this API provides you is not being updated by the actual minute. They don't have this sort of technology. What they do is they update it on the hour. I think they pull some scraping data from Google, not sure. Didn't ask. All right, so we do the results, then we're gonna just extract the historical data because we need both the historical data and the latest values, right? So what I want is essentially, I will create this schema where I will get the hour, the hour data, the venue, the day, and I will get the foot traffic, and I will match that schema with the online schema so that when I pull it, I can just essentially add those new values to the previous table. And let's do that, yep. Here is the only sort of engineering that's gonna happen. It's, I think, somewhat simple. What we do is we're just gonna, transform. So typically you could do that with a label encoder or this sort of thing, but I do it here. So I map the value of closed, low, or busy to a number, and because I want to calculate some sort of metrics of popularity. Here I'm just assuming that if a place is typically very busy at certain hours, perhaps it's more popular than the ones that are typically very empty always. That's a very simple thing. And I add that as a column. And what I'll do is then I'll just backfill that data into the feature store. And then, I'll set that up. That's for the query on the real time. So that will just get me the prediction of now. And I'll update that. It does exactly the same. It's just another job. So the only thing here that you need to see is that none of that is actually part of HopsWorks, right? This is just Panda stuff. You probably all know all of that 100 times better than I. The only part that's actually interesting here, in context of what I'm working on, is this. It's just an insert. And the way the only thing that matters in context of the backend engineering here is just that you have a script that does a bit of engineering, that this is consistent, and that you insert it at regular intervals, if that makes sense. The size of the data doesn't make sense. I mean, doesn't make sense. It makes sense, but it doesn't have a huge matter. Because if you would use large data sets, we'll use Spark behind the hood. If you do a very small data set, we'll use DuckDB behind the hood. But it's sort of not visible to you, so it doesn't matter. Alrighty. I think I did that. Now let's try to see if I can actually backfill anything. So this is the part where the real time is not real time, right? Oh, nice. Quota reached. I've did it too many times. So I reached the free online quota of the data on the feature group. So that's the person who tried the tutorial too many times just to see it works, just for it to not work on the moment it works. Chef kiss. Right. So anyways, what I got here is essentially all those columns and values of the busyness, if you will, the foot traffic of the location I queried. And I just parsed that, and I wrote it into a feature group. I mean, I didn't, but that was the intent. And so eventually, if I would run this, it will also update in the real time just the latest values of the same thing. Oops. And it does the same because it's also, it's the same table. For you, if you have a new project, you will obviously not have this issue, I hope. If you do, call him. If not, that's fine. So that's it. I think this does the same anyways. Yes, it performs the venue and everything. So what I can do, although I can't actually show you the feature group, I can actually show you the one that worked, like a few hours. So what we'll have here is the schema of that data set. You can also preview the data itself. You can do it just by calling head on the data frame as well. It's not that important. But what you have here is this object that has a certain cadence, right? So this feature group object here, this table, is highly dependent on the dimension in which you just define. You say, I want those bars in those locations. If I needed another location, or if it was a bigger location, it could be here, or it could be elsewhere. But every time I write this script, it will update that table, that feature group. All right, so let's try to move to training. It worked amazingly so far. All right, so this is sort of the same idea, right? What I will do is I will call the feature store, get back this table. I will actually do a view over that table, so I will map all the features I want to use for that model, and I will retrieve that. And the transformations will be applied upon retrieval. So because I didn't do most of my transformations here in the feature engineering process, like where I didn't do min-max scalars, I didn't do any encoding, I will do that on the retrieval. And actually, I will use them as functions. So I will just register those transformations, say, every time you call that column from that feature view, apply this transformation. So that means if I had another model with different transformations, it will actually be usable still. The column will still be usable. But it's also interesting when you do training data. The reason for that is because eventually, let's say you have the distribution of a column that may depend on the time. So if you have a column that your model just queries from 1 year, the year prior, and you apply min-max scalar on it, then all the data in that column has been changed in itself. And then let's say I have actually more data, but I have a different model. I want to do 2 years of that data. And if I apply the same scalar onto that column, the actual distribution would be slightly different. But if I did that on the raw data, it can't be reusable. I will need to re-engineer that pipeline. If you do it on retrieval, you can actually reuse the same column. Does that sort of make sense? Philosophically, let's say yes. All right. So I'm going to use an extremely simple model because I'm an extremely simple person. I'm going to use XGBoost. And there is sort of a reason for that. I mean, in my mind, is that from the little experience I have in data science, is like if I didn't get any sort of results using the most simple model I can get my hands on, probably there is either very bad feature engineering, no signal, or my problem is badly defined. But as I said earlier, I'm trying to do an MVP. I'm not trying to do something that will go to market with or anything. I'm just trying to prove to myself that there is a system that can be built, and I can get some output of that. So here I'm using XGBoost. So the rest is sort of similar. Let's just run it. Hopefully this one will work. Connected. Here I do two other things. I also call the model registry. So there is a feature store, but there is a model registry. There is a model serving. Sort of like the three main tools you need to actually do a system. I get back the feature group that I created this morning, not today, and show that I can actually query it. I did pick the right version, so it should work. Typically, if you have a good internet, this takes seconds. If you don't, it takes 9 seconds. Well, that's OK. So, so this is just to show that I actually have it. So one thing I did here is, the popularity. I will probably not use none of those for my model, right? Because it doesn't understand venue address, names, and days. Days, I will probably encode it. Business, it's already there. I will probably encode it as well. And popularity is just another metric. So what I do here is just pre-processing the data. This is the interesting thing, right? This is where I define this transformation function that I will need for this specific model. In my case, I only need 2 because they're sort of simple. So I will use the min-max scaler on the hour one and the label encoder on the day one. So then those becomes encoded. And I will just apply them on those features. So when I map those transformations to the features, what I can do is actually run this notebook. Nothing's going to happen here much. Here, I will create this secondary object. So I said we have a feature group. That's a table. We have a view. That's sort of like a SQL view over a table. This is where I will map all the, the features my model needs. In my case, I need the business. I actually probably don't need those 2, but that's fine. I need the latest updated and the business twice. Okay, maybe let's drop this one. I was maybe not too sober. OK, and that's my query. So this is what I get back from the feature group object, all the columns I need, and I will create this query, and I will just pass this query into the feature view. Now, in this feature view, there is absolutely no data. It's just a metadata envelope of the information that my model needs to actually exist. So I will also pass the transformation function that are required for certain column. So let's roll that. And now I should actually have the feature view here. Yes, more version of it. OK. So here, this is sort of the visualization of what the code earlier showed. So I have all the individual features that my model needs. I need a label as well, obviously, the target, what I'm trying to predict. And I will have the few transformations that I need to apply on those. In case of this feature view here, you can also have the version of the group of the table that you decided that you will use. So what it implies is you can actually mix and match. You can have different features from different versions of the same table depending on your use case. Given that this is just a metadata object, it doesn't really matter. It's just a mapping of the data, right? The other thing that I will show just after, which is in the code, is like you can generate training data from that. And you can do it from the UI. I never tried, so I should not do what I'm doing now. But you can choose the format that you prefer. Doing it in a notebook is sort of more funny because you just retrieve a data frame. That data frame is not saved, so you don't save data, but you save the metadata. You know that there is a new version of the training data that's been generated. And what that means eventually is that you can also map back to which model was using which training data, using which features, from which feature group version, and from which source. And so MLOps, essentially. Like you have a full lineage view of the data. It's all versioned. It's great. And maybe you don't need it, but that's fine. But it's also very convenient. So let's go back into the notebook. Here, I will just get the training data that I need. So it will query the feature group. It will query the feature view, apply the transformation, get me back that data frame, da-da-da. Sort of worked. So it will already do the train test split and validation split, depending on the proportion you want. I think in the new UI, we haven't see, new training data has been added. I think in the UI we even have that visually somewhere. Let's see. Mistakes were made here. So you can have the visualization of that. And you will also know what sort of data you have. In that case, it's not a format, it's in memory. It's a data frame, and you can just run it. So going forward, here there's a little bit of modeling. And when I say a little bit, I have to thank ChatGPT, because I have absolutely no idea what this hyperparameter tuning here does. But it seemed to work, so I just kept it. Right? So that's fine. But what I'm doing here is essentially just training and registering my model based on that training data that I just retrieved. And I'm going to pull out a confusion matrix to see if it sort of works. Spoiler alert, kind of works, not too well, but kind of works. So eventually, yep, here we are. And that's my model. So sort of imbalance here is my understanding. I'm not too great, but it looks like the model is sort of working. So at least we have a model. Eventually, it's just a matter of the scale of the data. So if at the first notebook here, I would have just probably put like 500 and all London, or 5,000 and all London, the data set would have been bigger, probably get a bit more results, or see if the results were actually relevant. But in that case, it's a sort of a very local model, so it works. So the only thing I need to do now is just register that model into the feature store and the schema, so that it's just available when I need to actually put it in serving. So I'll do that. Up in the model directory. I'll save the confusion matrix PNG because we have a UI, you can see it, and that's sort of great. And now it should be just writing into it. Yeah. While it does that, I'll just get back to this thing. I'll just tell you what we just did, essentially. Right? So in this, I don't know, 15 minutes, what I sort of did is just this feature engineering. I wrote into it. Then I didn't create an instruction data set or fine-tuning model. I just created a simple model, and I registered it here. You could do the fine-tuning step. There is a notebook in the function folder that sort of shows how to use Mistral, so you could use that. I'm, again, a very simple person. I'm just going to use OpenAI, and we're going to work on that. Eventually, this model is going to get enriched, and we're just going to ask the question, what is the best bar, get an answer, and see if that works. I don't know if it works, but we'll see. There is this optional test book that I kind of would like to go here now before showing the fine-tuning, because I think it's sort of interesting as well. It's the description as embeddings. So you don't have to run it. I can just show you what it does. What it does, it retrieves the feature group, and essentially it uses the feature store as a store, right? And what I do is I ask Google to find me, I think in the query here, to find me the venue names depending on the venue that I will provide it. I retrieve those venues here. I retrieve the description of those venues because it happens so that best time doesn't have the actual description of the venue. And then I just use a transformer model to create an embedding, and I will just save the embedding into HopsWorks. I could use that as part of my feature engineering process that I showed earlier and save it into the same feature group object. I was just playing around, so I sort of got that yesterday or the day before. So I was like, OK, I'm going to save that in a different object. But typically, what you can do once you have that, you can actually build a recommender system where you can call nearest neighbors on those embeddings, depending on the query, and you will have all that available. Here, I think I just stopped at saving it and call that. So that's why it's in the optional field here. But then, if I would have done that, not you, then you would have had that extract the text and compute an embedding step. That will be great for an actual recommender system. There's another thing that is not done here, but that's sort of the point of this sort of system, is that you can also retrieve information from the users. So in my case, I would pass that information into the rack, but if I use the function, I could also say, hey, given this user's history of liking tapas instead of pubs, perhaps suggest him this. But you could get back that history from a warehouse. And so you could augment that and be part of your feature engineering process. And the reason why this one is in a different color is like you actually don't need to do any engineering per se. You can just mount the data from an external table. So if you already have it somewhere, you just point it, say, this is where my user data is, and in your engineering and inference pipeline, that's how you would get it back. Alrighty, let's go on. So, yeah, training happened, it's there. I was just checking the UI if it's sort of there. No, model registry. All right, so I have 5 versions of this model, probably all from this morning, and just the F1 score, so to see if it works. So that's the model I'm using. Nothing atypical. It's just a storage, right? So again, it's made to be the least, I would say, interesting. That's not too true. The UI doesn't look that good here. It's made to be the least visible for you, because what you want to care about is manipulating data frame, doing the engineering logic, doing better models, and not really care about how, where, and why you store it in a certain way. And that's what we try to do. Here you will just have the input schema, the output schema. You can taste it, I believe. You can do some evaluation. You can create a README. You can deploy this model. So that will just deploy it in K-serve. I will not do that yet. All right. Actually, I don't think I have to do that. All right. Now that I have done the engineering, I have done some training, I can do some sort of inference. And this is going to be a sort of sans filet, as we say in French. So I didn't try this one. All right. Yep. Something appeared. What are you saying? Yes. So this is dying because it happens to my laptop. Typically because of this thing. No. Thank you, Ray. No, I'm joking. So anyway, one of the reasons is probably because one of the functions in this helper functions is either calling something that I didn't install or I uninstalled from this environment. But it's fine. It should be working for most of you. If it doesn't, let's talk after, right? But this should be working regardless. So in the case, it's exactly the same process. What I'll do is essentially get back my feature view, the right version of the feature view, get to the feature store, get that feature group if I need it, which I actually do not. I do get this feature view here, which is already there. And I will retrieve my model from the directory, version 3. Actually, should do version 5. All right. Up, get the model. Seems to work. Initiate OpenAI clients. Okay, what will be, the question is already written, so typically I just need to actually call it. But I have a feeling that this will not work because of the error I had earlier, so let's see about that. But yeah, so what it will pass to the question is essentially the feature view, the answer from the business model, and just initiate the client. I can just go here quickly to show you how this generate response work. So it's in this helper function here. What happens, I think it's actually more explicit in the Hermes Mistral one, where you can see that those functions are here somewhere. Okay, that's the generate response. Generate response OpenAI is here. It gets the user query, the feature view. That's the wrong model. That's maybe why it didn't work. Let's see later. And pass the date time and prints it. And gets the instruction. And the instructions are in this other one, context engineering. And here you have your function. So this is if I would have actually applied the function calling. So it will actually retrieve the function that will be calling the external model to predict in the future. In that case, we sort of hack it around, we just give it the output, and we hope it works. But typically, that's how you would do it in a more complex systems. Yeah. All right, let's try to call the inference. Yeah, because. So because it was calling another model that was not part of this notebook when it was querying this generate response OpenAI, which was the air quality model line that I removed. That model, I mean, that function is not part of this notebook. And so when it actually asked for it, probably it went into a loop or something and just didn't work. But anyway, I cannot help you with this information without current context or detail about pub or bar quality index. So something didn't work out, but sort of. Maybe I should rerun the whole thing. Let's see if that works. I get the right thing. Is this the right feature group name? Business under bridge. Let me just check real quick. I'm just gonna look at which training data. Yes, that's the feature 10. Okay, get the feature group, get the feature view. I have a bad feeling about it. Ooh. But you don't know if it hallucinated, in fact, right? So, and neither do I. So some debugging might be needed. But it says, for a great experience near London Bridge around this time, I'd recommend checking out the rake. And then it goes on to define, to say what's the rake. It is likely to be quite busy, but that's only adding to something else. I guess the coziness of the atmosphere or something. So yeah, sort of, we have a product. We have an end-to-end pipeline, an end-to-end from feature engineering to inference. It only took us sort of half an hour. It took me 3 hours, 4 hours, I would say, to build that out of all the notebooks we have and sort of my very, very limited knowledge in feature engineering. So I would say this is sort of a success. We may disagree. And yeah. So there is a few other actual pipeline that we can show. But I think what I can do is go back to my slides and see if I missed anything. So we didn't do the approximate nearest neighbor index because I didn't do the embeddings, but that would be sort of like future work. And once I have that, really, I just need a UI on top and I have an interesting recommender system. And then the only other aspects that would need to be built is that personal information side of thing. And that would be nice. Right? Do you want to go through the optional ones? Sure.
Yeah, no, just, excuse me. Yeah, so I think what this slide highlights, as I think Lex went into, is that there's a lot of moving parts. Even though you're just using Jupyter notebooks, there's a lot of moving parts behind the scenes which you are basically glossing over. But when you have to productionize something, that's where the complexity comes in. So underlying all this is, it's very simple. We just did one feature, essentially, or a set of features. But if you start to incorporate things like weather information or other types of information, then you have multiple feature groups, you have multiple features. You may try and train a model using certain features from certain feature groups and pull in other features. And over time, you'll have multiple versions, you'll have multiple training data sets, you'll have multiple models, and you're comparing one against the other all the time, right? And this is where, for startups, where they're basically trying to get something working, this is where you start seeing complexity explode, right? Because you're trying to manage the training data set. If that training data set we used on Tuesday is different from the one we trained on the weekend, etc., right? So so for example, if you had a weather feature group, you'd be pulling in weather information. Like you mightn't like to walk very far to the pub, right? And that would be a completely different set of features, and you may map that to the busyness of the hour, because if it's sunny, you might want to go to a beer garden, etc. And similar to what Lex covered, it's all very much the same. You're just basically creating feature groups. You're basically pulling in training based on that and doing an inference pipeline. Okay. Okay, so a lot of what you see as first versions, people just basically do some form of prompt engineering, right? Because that's easy and there's no fine tuning, there's no extra, and basically prompt engineering has become its own space. And that's essentially what the inference notebook does. Right? It takes context data, which is popularity of some description. Lex trained a model to try and basically model popularity, and then you just give that to your LLM, right, via some context in the prompt. So there's various different ways of improving prompts that everyone probably has heard of these: giving clear instructions, dividing large tasks into smaller tasks, asking for justification, generating multiple outputs and then give me the best one. These are all things that we'd have to incorporate into the notebook over time. And then there's even more techniques like few shot, chain of thought, etc. Again, we're going to basically incorporate those over time. So up to this point, we've only really done a conversational style best bar application. We haven't really done anything to do with recommendation systems. So if you're a person who's big into recommendations, that is somewhat deliberate, because I think what we were interested in was, can you build a recommendation system just by using an LLM with some context data, right? We didn't put a UI around it, but if you use Streamlit, it should be fairly straightforward to put a simple UI on it. You can use various different LangChain components to make it even more interesting. You can basically call out using this SERP API wrapper. You can basically use memory. So if you have this conversation style application and you're doing multiple messages, you can basically use the history. But we haven't talked about a recommendation system at any point. So if you're big into recommendation systems, apologies. But there is loads of interesting stuff happening in the recommendation space. There's this P5, and I think for future work, we're probably going to do incorporate a recommendation system with a large language model. Okay. Do you want to cover this? Thanks.
So what's missing to make it an actual system? The main thing is the orchestration, because all what I did here was just running the notebooks, asynchronously. This should not be fairly hard. In fact, you can probably just do a cron job with the first notebook, or make it a script, and you have it. You have your whole feature engineering pipeline, which is the part that you need to orchestrate. In our case, we would use your Airflow or something like that. We didn't use the recommender, as mentioned, sort of part of the plan. I was a bit optimistic in a couple of days to build this thing, but it's all right. And the RAGs and the UI. I kind of would like to just show you the complexity of what's behind, right? Because what you've seen essentially is just the interface of, you've just seen the interface to which we would talk with the notebooks and all. But what I can do is actually show you why this interface matters when it comes to systems. So when you build this sort of tables, you want to version two things. You want to version the schema, and you want to version the data. And that's for that's at least for one reason. Obviously, you want to version the schema because if you drop a column, your model doesn't know about it. That's going to be problematic. So if you have schema breaking changes, it's better if it's versioned. But that also means that you can roll back to different tables if you version it properly. Now, you also want to version the data itself.
And that's something that most of the tools and stuff don't do. I'll just look at the activity here. In our case, we do this as a commit system. So we use Hoodie under the hood for that. So that means that we have Hoodie and hopsfs on top of Parquet files. So we essentially give acidity to the files. So you can go back in time. So if I need to retrieve the data as of this point in time, I can. So if an auditor comes and say, hey, you have looked at the data, you have created this model with this sort of data, can you show me what it looks like? Well, in our case, yes, you can. But this is the sort of things that you don't necessarily think about when you're creating just a machine learning model, but that are obviously very important when you create a system. Then, as I mentioned earlier, the transformation function, that's sort of self-explanatory. The provenance is as well. But there is like cool stuff that happens under the hood when it comes to expectation rules or taggings or all that. I didn't do expectation rules. Should probably add some. So great expectations, I'm sure most of you know, so that will be just validation rules. In our case, you can just attach the expectations right to the feature group, and all of the individual column or the data before being written to the feature group will be looked against the expectation. And then you can either prevent the write or things like that. You can also consider this object as a streaming feature group, as an online or offline, as I said. So offline would be Parquet file. Online would be in-memory database. We have ROMDB for that. And then you can use the sort of external feature group as well, which would be mounted tables, so no write. Feature views I mentioned, storage connectors, self-explanatory. We do have Jupyter on the platform, not for the serverless, but we do have it on the enterprise. So then you can do a bit more cool stuff, which is you can have your own Python environment per project. And in that case, each Python environment comes with its own history. So if you actually added new libraries to that Python environment, that may break just what I did earlier, that breaks sort of the pipelines and all, you can look back at that history and say, hey, well, by the way, what was the difference? In this case, it was just adding everything. But if it was just updating the Python library, that would have worked the same way. You can also add custom comments. Obviously, what we don't show when we do all of those what we don't show when we do all of those read, writes is all the underlying engines that we are using. So in our case, we're using different technologies, obviously, but we use Spark when we create the jobs for certain data, so Spark and PySpark. We also use DuckDB to do the query. So the reason why it doesn't have to launch a Spark stuff, and when you retrieve it, you can just do it in a few seconds from the tables, just because we're using DuckDB and Aeroflight under the hood. We also use Kafka as a topic manager. You can use your own Kafka. So that's sort of like the platform as a whole, mostly made to just abstract away all of those sort of management systems that you need to handle. And here, in that case, if I was using this one, I could just schedule a job, and I could just use the notebooks I had in this workshop, and just say, all right, schedule this and run this every day or whatnot, or every hour. And that will be just it, or use any external. I think that's sort of it. A bit early, but I'm fine. We do have Elasticsearch, so it's open search under the hood as well, so you can do search across all the projects, etc. Obviously, this is not what we are covering here, but that's it. I should just shout out that we have this GitHub repo, which is called Hopsworks Tutorials. It has not this one, it has a lot of more tutorials in there. So you will have like the one that it is based on, which is the air quality one, which is slightly more advanced, I would say. Here, air quality tutorial. Slightly better done too, I'm sure. So then you will have the same logic, feature training, inference, but with a UI and the air quality in real time, depending on the location. And this one does use a function calling. And so you can sort of have a good look at this. And if you are more into non-LLM use cases, we also have my favorite one, which will be the fraud, which actually showcases the online fraud systems. So this one doesn't have an LLM. But we have other cool ones, LLM, PDF search, and stuff like that. I invite you to have a look. None of those notebooks require you to have an enterprise version of the platform or any of that things. You can use only the free versions on serverless forever. And that's all fine. Yep, that's all I got for you.